1, booster ignition, and liftoff. Artemis 2 now bound for the moon.
Imagine waking up, looking out your window, and seeing Earth hanging silently in a black sky. No blue atmosphere, no birds, no oceans, just dust, rock, and the most ambitious human construction project ever attempted. Because within the next decade or so, humanity may begin building its first permanent base on the moon. And once that happens, everything changes. For more than 50 years, the moon was a place we visited and left. Apollo proved we could go. But now the question is different. Not can we reach the moon, but can we stay there? NASA believes the answer is yes, and the plan is called Artemis, a new generation of missions designed not just to land astronauts, but to create the foundations of a long-term human presence. A true moon base. This won't look like science fiction cities with giant glass towers, at least not at first. The first lunar base will likely be practical, compact, and built for survival. Think habitat modules, power systems, communication towers, storage units, rovers, radiation shielding, life support. Every bolt, every wire, every kilogram will matter, because on the moon, there are no hardware stores, and the moon is not welcoming. Across its surface, temperatures swing wildly. From roughly 127 degrees Celsius in equatorial sunlight to minus 173 degrees Celsius in darkness. And inside the permanently shadowed craters near the South Pole, they can plunge to minus 240 degrees Celsius, some of the coldest places in the solar system. There is almost no atmosphere. Micrometeorites strike without warning. Dust is razor-sharp and clings to everything. Radiation exposure is far higher than on Earth. A simple mistake there can become fatal very quickly, which is exactly why building a base on the moon matters so much. Because if humans can live there, we can learn to live almost anywhere. So where would this base go? Not near the equator where Apollo landed. The most likely region is near the moon's south pole. Why? Because some crater rims there receive nearly constant sunlight. That means more stable solar power. And deep inside nearby permanently shadowed craters, spacecraft have already confirmed the presence of frozen water ice. Water changes everything. You can drink it, split it into hydrogen and oxygen, create breathable air, create rocket fuel. A moon base with water is not just a camp. It becomes a fueling station for deep space. And that's where the real story begins. The moon may be less about the moon and more about Mars. Launching from Earth is expensive because rockets must fight gravity and a thick atmosphere. But the moon's gravity is only about 1/6 of Earth's. Imagine building spacecraft there, fueling there, launching from there. A lunar base could one day become the first shipyard of the solar system, a stepping stone to Mars, asteroids, and beyond. But how do you actually build something on the moon? You don't start by sending hundreds of people. You start with robots. Autonomous machines could arrive first. They may clear landing zones, move regolith, the moon's dusty soil, set up solar arrays, prepare foundations, even 3D print structures using lunar material. Yes, the dirt itself may become building material. Instead of shipping bricks from Earth, you manufacture them there. That single idea could save billions. Then come the humans. Short missions first, weeks at a time. Testing systems, repairing machines, expanding habitats, learning what daily life truly feels like. Sleeping in 1/6 gravity, growing food in controlled environments, managing stress in isolation, recycling air and water constantly. Every routine on Earth must be reinvented. Even walking is different. Even time feels different. And imagine the psychology. Step outside your habitat. Look up, see Earth as a bright marble in darkness. Every person you know, every city, every war, every love story, all of it contained in that small glowing sphere. Astronauts often describe a shift in perspective after seeing Earth from space. A moon-based crew might live with that perspective every single day. And no single nation will carry this perspective alone. Because this vision is not being built by one country. NASA leads the program. But Europe is building key modules for the orbiting Gateway station. Japan is developing pressurized rovers capable of driving astronauts for weeks. Canada is contributing the next-generation robotic arm, Canadarm3. And more than 50 nations have now signed the Artemis Accords, a shared set of principles for peaceful exploration. Private companies are everywhere too. SpaceX is developing the human landing system. Smaller firms are sending the first robotic landers, carrying cargo and science. The moon has become a collaboration, a place where engineers from across the world pour their best ideas into the same plan. No single country will own this base. It will belong to humanity. Now, imagine what daily life there will actually feel like. You wake inside a thick-walled habitat, reinforced against radiation. The light is artificial. On the moon, sunrise takes nearly 14 Earth days, and night takes 14 more. Every movement feels lighter, slower, almost dream-like. You check the oxygen levels, the water recyclers, the dust seals on every door. Because lunar dust gets everywhere. Breakfast might come from a small greenhouse module grown under LED light. Then you suit up. It takes close to an hour just to get ready to step outside. Once there, you walk across a grey plain under a black sky. No wind, no sound, just your breathing and the soft hiss of life support. And you realize you are one of the few humans in history to stand somewhere other than Earth. The first moon base will probably seem small, cramped modules, dusty machinery, endless maintenance, not glamorous. But neither were the first polar stations, the first ocean outposts, the first airfields, the first computers. History often begins in ugly prototypes. Then suddenly, the primitive becomes normal. One day, perhaps decades from now, lunar residents may laugh at how difficult the beginning was. They may commute through tunnels, grow plants under domes, manufacture spacecraft, study the universe from radio telescopes on the far side, shielded from Earth's noise. Children may be born into a world where going to the moon sounds ordinary, and it all may start with a few machines, a few brave crews, and a base of metal and dust beneath a black sky. So the next time you look up at the moon, remember this. It may no longer be a distant object in the night. It may be the next address for humanity. And when the first lights switch on there, we will never again be a one-world species.